5, where we will discuss ecosystems and restoration ecology. An ecosystem is considered to be the sum of all organisms within an area that are interacting with each other. An ecosystem will also examine the flow of energy and chemicals within the system. Energy flow, depicted in the orange arrow at the top of the diagram, is considered to be one way, whereas chemical flow is considered to be cyclic, depicted in the blue. This is because nutrients are typically returned to the system where they can cycle through again. Most of the energy that enters into a system will enter in as sunlight, where it will then get converted into chemical energy through the activity of autotrophs. This energy will then get passed on to other organisms in the form of organic molecules. However, much of this energy will get dissipated off as heat energy through metabolic processes. Carbon and nitrogen will typically pass between biotic and abiotic components in the system. Carbon and nitrogen are typically taken up by photo and chemoautotrophs from the surrounding air, soil, and water. These elements will then be fixed into organic compounds that are then consumed by other organisms. These elements are also returned to the system as waste material and dead animals that are broken down by decomposers. The flow of energy and chemicals within an ecosystem are governed by physical laws, such as the conservation of energy, the law of entropy, and the law of conservation of mass. The conservation of energy law states that energy is not created or destroyed, merely it is transferred or transformed. This is true as much of the energy that is being transferred through a system is converted into heat energy. Though it is considered to be lost from the system, it is not lost in the form of energy. Law of entropy states that entropy or disorder is always increasing. This means that in order for systems to be maintained, energy must continuously enter into the system. And finally, the law of conservation of mass states that matter cannot be created or destroyed. This allows for the determination of how a chemical cycles or is gained or lost within an ecosystem. As examined in the previous lecture, species can be grouped into different trophic levels that are based on their feeding relationships. These trophic levels are typically described as primary producers, consumers, primary, secondary, or tertiary, as well as decomposers. Primary producers form the base trophic level that supports all other life forms. This typically includes the autotrophs. Primary consumers are usually herbivores that rely on the primary producers for food. Secondary consumers are the carnivores that eat herbivores, and tertiary consumers are the carnivores that consume other carnivores. Decomposers are considered consumers that get their energy from the breakdown of detritus. Detritus is considered dead organic material that includes dead organisms, feces, as well as dead vegetation. Primary production refers to the amount of chemical energy that is produced by autotrophs over a given time period. The initial input may be from light, as in the case of photoautotrophs, or chemical, as in the case of chemoautotrophs. The value of primary production sets the limit for the amount of energy that is available within the ecosystem. Even though the sun provides a large amount of energy in solar radiation, only a small amount is actually used for photosynthesis. Much of this energy is lost as it hits surfaces that don't photosynthesize, like rocks and soil. This energy can also be transmitted or reflected or lost as heat. Note that when we say lost, we mean that it is lost from being used in the system. Only certain wavelengths are going to be absorbed by different photosynthetic pigments, meaning that not all of the energy that is absorbed will be usable light. We are now going to focus on primary production. Primary production can be estimated by calculating the gross primary production or GPP value or the net primary production value or NPP. GPP is considered to be the amount of energy from light or chemicals that is converted into chemical energy per a specific unit of time. Net primary production is the GPP minus the amount of energy that is used by the primary producers, which is denoted by RA. Primary producers, keep in mind, still have their own metabolic needs. This means that some of the energy that they are absorbing is going to be used to support themselves. The NPP is usually expressed as energy, or biomass. NPP is equal to the formula below, GPP minus RA. Some important points to consider when examining the primary production levels. Even though a forest may have a large amount of biomass, it may not necessarily have a large NPP value. This would occur if animals are quickly consumed by plants, keeping the accumulated biomass levels very low. On average, only about half of the NPP will make it into the rest of the ecosystem. Once again, illustrating the inefficiency of energy transfer between trophic levels. This slide depicts the global net primary production levels on Earth. Note that in general, the tropical forests, which typically have green, yellow, orange, and red net primary production values, are considered to be the most productive ecosystems. As a result, they contribute a large proportion of the energy to the global NPP, even though they are restricted to various locations, usually close to the equator. Also note the vast landscapes, such as the Antarctic as well as Arctic and desert regions that are considered to have very low net primary production values and are denoted in black or in gray. The net ecosystem production is denoted by NEP. This is defined as the amount of biomass accumulation from primary producers and consumers during a specific time period. This is typically evaluated by measuring the net flow of carbon dioxide or oxygen entering or leaving into a system. NEP can be calculated by taking the global primary production minus the RT, where RT represents the total amount of respiration for all organisms within the system. NEP gives an estimate for the total amount of carbon that is lost or gained by an ecosystem over time. Keep in mind that carbon dioxide and oxygen levels are directly linked to photosynthesis as well as respiration. When examining aquatic systems, primary production is primarily limited by two main factors, light and limiting nutrients. The depth of light penetration in the aquatic environment determines the level of primary production in the photic zone. Thus, it plays an integral role in determining the amount of energy that is available within the aquatic system. Certain elements can also be considered limiting. Limiting nutrients are considered to be scarce in their abundance, and in aquatic systems, this has a direct role in determining the growth of primary producers. When present, these elements, such as nitrogen, phosphorus, and iron, are quickly used up by phytoplankton and then eventually lost from the system through the production of detritus. When limiting nutrients suddenly become abundant in systems, eutrophication can occur. This means that nutrient-poor regions suddenly become nutrient-rich in one of these limiting nutrients. Algal blooms occur when excess nitrogen or phosphorus from fertilized agricultural fields run off into the surrounding waters. This releases populations that were previously limited by these nutrients. Although algal blooms are considered to be a natural occurrence in bodies of water, they may become harmful if there are not enough grazers in the ecosystem, if they are artificially introduced by agricultural practices, or if the nutrients are constantly entering into the system. Blooms can be also harmful as some algae are known to produce toxins, and large blooms can create zones of stagnant, low oxygen water. This is because the water underneath is not getting any access to light. As a result, this will create dead zones underneath the bloom. When we consider primary production levels in terrestrial ecosystems, they are primarily limited by three main factors: temperature, moisture, and limiting nutrients. As temperature increases, this is usually correlated to higher levels of solar radiation. This can then be used by primary producers. Higher levels of rainfall can also provide the water needed for photosynthetic processes. Together, hot and humid environments are considered to be the most productive, as we can see in the tropical regions. As we've seen in aquatic systems, elements such as nitrogen and phosphorus can also be limiting in a terrestrial environment. This is because plants require large quantities of these elements. Climate change has a direct effect on the levels of primary production. NPP values are affected by climate change, as well as NEP values. When examining NPP values, though climate change has caused an increase in NPP values for certain tropical regions due to the higher levels of solar radiation, this is offset by the level of desertification in larger spans of land. In addition, climate change has led to more disturbances and more extreme weather conditions, such as droughts, wildfires, and has also been associated with pest outbreaks. This has led to an overall decrease in the NPP value. When considering NEP values, these can also be altered by climate change. In general, if the NEP value is greater than 0, this means that the ecosystem is gaining more carbon, and this system would act as a carbon sink. If NEP is less than 0, this means that the ecosystem is losing carbon and acts as a carbon source. Thus, usually this is done through the production of carbon dioxide. Research has shown that climate change can cause the ecosystem to switch from a carbon sink to a carbon source. This means that the system can contribute even more to climate change as excess carbon dioxide is produced from the system.